Testing. 1, 2, 3. Okay, ladies and gentlemen, let's go ahead and get to it. All right, it's good to see you. I hope you all enjoyed the film on Monday. Today, it's back to work. We're doing some programming, okay? Now, I want to show you a little bit of programming today. In fact, I want to show you a little bit that I forgot to show you last week. So one of your tasks was maybe slightly harder than it should have been because I just forgot to implement that part of it. But I also want to kind of talk more generally about scripting in Unreal, right? How many of you are starting to feel a bit more comfy with like, hey, I'm going to make a blueprint or a component and I'm going to start coding. I'm going to make certain things happen, right? I've got my lifecycle functions, okay? Not too many of you, but some of you. How many of you feel like you have a good read on how the interaction affordance system works? Now, that's the thing we implemented together, okay? I was up here, we're pointing at stuff, we're triggering light switches, right? We had the poster that we made, okay? The good news is that I usually don't make the poster with you, okay? Usually I skip that one, you have to make it by yourself. The bad news is that I accidentally skipped a part that we usually do, but we didn't do this time. So we'll do that in just a moment, okay? So give it some more time, all right? You've got some more time. Your P1 Alpha, if we look at the schedule, is not due yet. It's due on Monday, okay? I'll tell you, the P1 Alpha, have you looked at some of those tasks? Okay, you've got some pretty serious tasks in P1 Alpha, okay? The whiteboard, you've got, I think, NPC dialogue you have to do, okay? You've got a time of day, okay? As you interact with things, the sun goes up and down. These are not trivial tasks, okay? Not easy at all. And so please do not underestimate them. It's Wednesday. You've got a handful of days remaining to attack these, but please do not sleep on them, okay? It's going to be a very unpleasant night if you wait until Sunday. In fact, it might be a pretty tough time if you wait till Saturday or even Friday. So please, at the very least, experiment a bit. See if you can knock out tiny little bits of these tasks right away, okay? That'll make your life much easier. Okay, so let's go ahead and I want to show you a company before we get into all that, okay? I want to show you Obsess AR. This is a company that is kind of interesting, okay? They've got a beautiful website. This is actually something that I recommend you do as you go into P3. A big part of P3 is going to be how do you present yourself? What is your team? What is the product that you're building? And having an excellent website, ideally with footage of the project being used, ideally with a nice logo, tagline, right, is going to go a long way toward kind of selling your vision, selling your project, okay? And so you'll want to think a bit about that. This is a company that makes basically VR experiences, okay? They make VR and AR experiences. And interestingly, right, they work with a ton of different brands and companies. Corona, Disney, Johnson & Johnson, Crocs, okay? Okay, I've got a question for you. How big, how well funded do you think the internal Crocs VR team is? I want to know how many people on that team and how many millions of dollars are they getting to build out the VR Croc stuff. Don't be bashful, okay? You know in your heart, how big is this team really? How big is it probably, okay? I'm just seeing like nods. Zero, right? Zero, exactly, okay? Now, I don't know that for sure, okay? Remember, the Quicken Loans team, the Rocket Mortgage team actually has a handful of internal game developers who use Unreal Engine, who use Unity to build exhibitions, visualizations, all that, right? But chances are Crocs or even Corona or J. Crew, they are not going to have their own internal developers, okay? VR, AR, game dev developers, okay? So, I mean, it simply wouldn't make much sense, right? Is Corona in the business of making VR applications? No, right? Not really. And so often what you discover is that you'll have some sort of brand like KFC, right? They'll make a game or a VR app or an AR app. However, under the hood, hidden, out of sight, is a company like Obsess AR, okay? Have any of you heard of a game development studio called Tosei? Let me see here. Tosei Game Studio, Wikipedia. Let's take a look. Let's see if Wikipedia knows about them. They do, okay? Have you ever seen this logo before? You probably haven't, okay? They have made a ton of games. They have been around for 44 years, since basically the start of the industry. They have made all of these games. My goodness, the list just doesn't stop. Let's see if we can find some modern games. PlayStation 2, DS, Switch, okay? Did you know that they worked on Paper Mario Origami King, Splatoon 2, WarioWare, okay? Final Fantasy, all right? Dragon Quest, right? Resident Evil. So this is one of those companies that their business model, like you sometimes won't even find them or any of their developers in the credits of the game that they made, okay? They are a ghost developer. You'll hire them if you want to make a game, but you don't have the bandwidth or resources or talent to do it right now. You might pay a little premium because they're going to come develop the game and then they will take no credit, okay? They won't take any credit. That seems a little bit weird to me. Like, that feels even borderline unethical. But they're a company, and that's their motto. They're going to show up, do a good job, and then they're going to take no credit, disappear, and you can hire them for your next project that you need them on. Okay? Sometimes this kind of company simply exists, and you might not know they exist. They're a ghost developer. And Obsess AR, that is maybe a little bit of what they're into, okay? If you are NBC Universal and you don't have the internal talent or time or resources to build a VR store or some sort of experience for an exhibition or an event, then you can hire Obsess AR and they will come in and do that. All right? They have already done this for a ton of different brands. They're very good at kind of pivoting themselves to work with your brand, okay? And they can reuse a bunch of technology they've used for other partners to quickly make yours, okay? So they say that their customer engagement is really good. In particular, they love to help brands set up VR stores, which I've never had the desire to go shop in VR, right? If I go into VR It's because I want some sort of training, right? I want to be inside of a Cessna 152 to learn about the controls on the dashboard in VR. Or I want to go to Mount Everest in VR and I want to get a fraction of what it feels like, okay? But apparently, they've got numbers here, right? 116 million plus consumer interactions in stores that they've made, okay? Drive brand equity and loyalty. 10 times higher time spent than traditional e-commerce. So I guess they're saying, or they're trying to imply, that if you open up a virtual store, people spend a lot more time in those VR stores than they tend to spend in IRL stores, okay? Tap into first-party data, 70%, okay? People who go to virtual stores are more likely to sign up for your newsletter, right? Or to offer their email and sign up for purchases and stuff like that. So one reminder, these numbers sound pretty good, okay? Are you convinced? Are you going to drop the money right now to get your VR store made? Well, maybe not, but if you have a budget, if you are working at, Ralph Lauren, and your CTO says, hey, I'm giving you $10 million to go figure out how to resonate with the kids, because the kids just don't like Ralph Lauren these days. I don't know, right? Maybe you're convinced to spend some of that money on trying out a VR app, okay? However, keep in mind that these statistics are not backed by a big paper, right? They don't show their methodology on how they collected these numbers, okay? This is not peer-reviewed. And so, they might not be lying, but they might not be entirely honest either, okay? If it says, hey, did you know that customers spend 10 times the amount of time in our VR stores as they do in the normal store, is that because it takes quite a while to get the headset on and get comfortable? Is that because they get into your VR store and they're trying to figure out how to move around because this is their first VR experience? You don't know, okay? And if you ask, they're probably not going to answer, but maybe they will. Who knows? Anyway, let's take a look. Roblox partnerships. So they'll also build a Roblox server if you want them to. Okay. So you can see, yep. Apple Vision Pro, design and development services. Okay. So if you're trying to get stuff out for the Vision Pro launch, you could do that. Blah, 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 blah. It's interactive. Okay. Customers, American Girl, Amica, Crate and Barrel, e-commerce integrations. So if you want to sell stuff, we'll set that up for you. A question. When you buy something in the state of Michigan, you are a part of that transaction, and the store you're buying from is a part of that transaction. But there's one more party here that affects the transaction a little bit. In fact, you could say they affect it by about 6%. What other party exists in that transaction?
Government.
That's right. The state of Michigan is going to tax that transaction, and it's going to cost about 6% more, okay? Here, right, they're going to set up e-commerce so you can sell things to the customer, but in this case, they will be the ones taxing that transaction, okay? Have you ever heard, right, platform over product? So if you get into entrepreneurial circles, and not everyone agrees with this or thinks it's a good thing, but if you get into entrepreneurial circles or VC circles these days, if you want to raise money or build a big successful company, most of the time people care not about products, but about platforms, okay? And this is why, right? Obsess AR will make a store for you, and they'll make some money doing that. But you know what they would rather do? They would rather tax 6% or maybe 10% of every purchase that happens in the digital world, okay? The metaverse, all right? And so they'll create a platform to try and make that happen. How many of you own a game console of some sort or have downloaded a game on Steam? Okay, a lot of you. Do you know how nice Valve has it right now? The creators of Steam, Valve, Gabe Newell creates Steam. How does he make most of his money? He puts in a ton of work to make the latest, greatest video game and sell it. Sometimes he does that, but most of the time he's making money on every sale on Steam. It doesn't matter who's involved with that sale. It could be Electronic Arts or Activision or Tencent or a small indie company. How much of that sale does Gabe Newell get? 30%. Okay? People complain about that 6% sales tax from the state of Michigan. And here's Gabe collecting 30%. Okay? That is why a lot of people really care about platforms, not as much about products. Okay? Though I personally like making products more than platforms. But if you want to make a ton of money, get really big, it's about platforms, all right? Gabe Newell gets to go enjoy New Zealand and sit on his butt, and he'll be making millions of dollars a day for a very long time, no matter what, okay? Unless someone shows up with a big Steam competitor. Anyway, okay, enough tangents, all right? I think we got enough here. It's a cool company. It's very impressive. They've been around for a long time. This is a company that has a lot of talented developers, you can tell, from 3D modelers to general technologists who can implement and execute e-commerce stuff, who can build interactivity. And these environments actually look pretty good. I was impressed with this initial video. Like, dang, they implemented the exterior of the building and everything. What is this, like a Macy's store? What is it? Crate and Barrel, okay? I don't really go to high-end stores. I don't really care that much. But, yeah, looks pretty good. Okay? Technology, blah, blah, blah. Resources. Okay, I think I'm done here. Okay? Anyone have any comments on this company? I've got a comment. Okay, financial sustainability. It's pretty clear, right? They're selling. You can pay them and they'll build a store for you. They also have a lot of opportunity to tax any transactions that happen in that store. They're in a good place financially. I think that's pretty clear. Novelty, right? It kind of cool, right? Not super special or unique. XR emphasis, this is all about VR, so it's right there. It's all good. This is the one I care about. Social impact. What is the social impact here of helping brands create virtual stores more efficiently than they could on their own or more effectively? What's the social impact here? If this company doesn't exist, then J. Crew and Crate and Barrel don't have a virtual presence. Okay? Is this like a world-ending kind of dilemma here? If J. Crew doesn't have a virtual store? Can you imagine anyone alive who might be pretty happy that there's a virtual store that they can visit over the internet that they don't have to drive to? Someone who can't move very easily, or maybe travel is just very difficult or painful or super expensive for them. If they have a VR headset, maybe, if they're a big fan, they can get to these stores and at the very least kind of feel what it's like. It's not perfectly authentic, but they can get that experience at least a little bit.
I think specifically the wardrobe planning one, like for disabled people or really anyone.
Sure, right? So maybe you don't have a whole lot of spare cash to burn. This is your one chance to do some shopping, and you want to get a kind of a better look at some of that up close and personal stuff, right? The wardrobe, experiment, customize some stuff. So I don't think this is the most impactful company in the world, but to say that it is completely useless, I don't think that's accurate either. I think that there's going to be a niche for a company doing this kind of thing, all right? As we're going to find out later, sometimes a niche is all you need, okay? So anyway, interesting to think about this stuff. Interesting to see these companies, yeah? All right, so I've got a couple announcements for you. Your skills are in high demand, okay? And nowhere more than actually at this university, right? Some of you maybe want to go work at Niantic, okay, work on Pokemon Go, work at Pixo VR, work at some VR or AR shop. But universities and academic groups are, in many cases, the ones who are pushing these technologies forward and finding really interesting use cases for them. A good example of this is Professor Nebling's XR laboratory. It's called the School of Information Interaction Lab. And you can go there. It's just my2lab.com. Michael's always creating really interesting new software and solutions, sometimes some hardware solutions, to allow people to do different interesting things in VR and AR, okay? And they will happily take on some of the students in classes like this because you've got some very surprisingly mature skills, okay? Let's see here. If you click on this Jobs and Internships button at the top of Canvas, you'll see that I have a big XR and Game Dev Get a Job guide. This was put together in collaboration with recruiters in the games industry, in the XR industry. And one page that I want to really point you at in terms of XR is the third page, Academic Opportunities, okay? This campus has a ton of laboratories, right, that are actively in need of good VR and AR talent, okay? They've already taken quite a few people from this course, and they often ask me, like, okay, who do you got? You got anyone, right? And what I recommend is if you're looking for a summer job or looking for a job during the semester even, or if you even want to get a letter of recommendation for grad school, okay, this is perfect, okay? I've got instructions on how to reach out to these people. Send them your project. Send them your resume. You can click on the link to see what kind of cool stuff they're doing. But this is a really, really good way to get a letter of recommendation. Okay, how many of you are thinking about grad school, maybe? Okay, how many letters do you need to go to grad school? You need 3. Okay, you got 1. You do a good job in this course, I'll write you a letter. Okay, and if you go and work for one of these labs, you've got 2. Okay, and they're going to be able to write a really good letter because they'll watch you in a research context. Okay, and then you only need 1 letter, and if you got 2 really good letters, maybe that gets the job done. Okay, so keep that in mind. I encourage you to apply, at least reach out, say hi. If you think their project is awesome, let them know that. Okay, that always feels good. Get emails like that. All right. So anyway, look through this guide. Don't neglect it. It's there to help you, and we've seen a lot of hiring happen over the years. Okay, so we're trying to help you get opportunities like that. Okay, breaking news. Apple has created their very own game engine. Can you believe it? And as I show you this footage, I have a feeling it's going to look a little familiar. Okay? Now let me know if this looks just a little bit similar to something else you've seen recently. Okay? Now remember, Apple only does the most new and novel stuff. Oh no! What happened? It was blocked? No way. You know, I showed this exact video to 494 students like 2 or 3 days ago on Monday. All right. So I think it seems Apple was offended that I was making fun of them a bit. Let's see. Apple Reality Composer Pro. Okay. I think I can find it here. Yeah. Okay. Here we go. So let me know if this looks a little familiar to some of you.
On the trailing side, we have the inspector panel. The inspector panel provides an easy way to edit the properties of selected objects, such as the position, rotation, and scale. The Add Component button on the bottom of the inspector panel also lets us view the built-in reality kit components that we can configure on other objects.
Did Apple purchase Unity? Did they? If I'm Unity, I'm either feeling very salty or very flattered. Okay, so Apple has created a new game engine. Okay, they won't call it a game engine. Apple has always been a little bit wary of the term game. I think some companies just see it as a bit more of a toy. But this is Reality Composer Pro. It is a Unity clone, a very lightweight one, and they've built this in anticipation for the release of the Apple Vision Pro. Okay, it is cool to see yet another team getting into that space. And if you take the game engine architecture course, you will build your own game engine that has many similarities to this. But it's kind of interesting. Apple has an interesting kind of company culture. They have an interesting style where they will wholesale rip off Unity, present it as something very, very new and fresh. And sometimes that works. Okay, sometimes it works. Okay, so I would like to give you some quick tips for Project 1. So as you work on P1 Alpha, this might be one of the hardest weeks you've had, okay? Because the interactions and the code you're writing is going to be a bit more intricate, okay? You're writing components, right? And you're writing blueprints, okay? You're adding logic to all these things. Sometimes you want code inside of your components to be able to reference the actor it was placed on, okay? So for instance, if I've got Unreal Engine right here, and I add a component to this cube, sometimes I want to write the component so that it moves the cube, right? But in order to move the cube, we need to get a reference to the actor that the component is on, right? This cube is an actor. This actor has several components, okay? It has 2. I know it looks like there's 3, but you'd never consider the top one, okay? It has 2 components, and these components, if I write another one, might want to be able to move the actor. Well, the component, in order to move the actor, has to get a reference to the actor that's on. And this is, if you've used Unity, this is like writing game object, okay? Instead, in Unreal, you'll use the getOwner node, okay? Not getParent, getOwner. And that's going to get you that cube. It's going to get you whatever actor this component is currently on, okay? And that allows you to do things like despawn the actor, or move the actor, or launch the actor into the sky, whatever you want to do, okay? One question is, how do you communicate between components? Because sometimes you'll have a component like AF_message, and maybe it wants to grab this static mesh component and turn it off, or get rid of it, or change the model, okay? So that it looks like a different character. Well, how do you do that? Well, you can write code that allows us to get that other component, okay? What you can do is use the getOwner node, like we just talked about. That gets you the actor, and then you can follow that up by using the getComponentByClass node, okay? So we grab a reference to the actor, and then we use this component, this function, this node, to grab the particular component that the actor currently has, okay? So this is the equivalent of getComponent if you're used to Unity or if you've taken the game engine architecture course, okay? All right. And we're going to talk more about this in just a little bit, because today my main objective is I want to talk more generally about programming in Unreal, okay? Have any of you ever looked at a power line or some sort of cable management situation and gone, oh my goodness, I don't want to touch that with a 10-foot pole, okay? Especially if it's a metal pole in the case of the shenanigans happening here. I think, I don't remember where this image is depicting, but sometimes when you're doing infrastructure, it just gets crazy, right? And you can fix this. You can make it much more organized, but that takes some time, okay? And not everyone is going to be able to take that time, and so that's what happens, okay? Very nasty. Tell me this, what happens if something goes wrong on this pole and you need to like get in there and fix something? If you ever need to understand what's happening here, what do you do? Give up, basically. Move on with your life. Find some other objective, okay? Go read a book. Go become a farmer. That's probably what you do, okay? Farming is awesome, by the way. Don't sleep on that, okay? All right. So if you get into Unreal and you program in a suboptimal way, there's a chance that you could end up with a very spaghettified, very nasty situation like what we see in this image, okay? Just because we've moved to a visual scripting situation does not mean that the topics of coupling, okay, and spaghetti have gone away. Poor organization, right? You can mess up a code base the same way you can in a textual code base, okay? So hopefully you will keep your components and your logic as small as possible. What you can do is something you saw us do last time. Do you remember what we did when we implemented the VR pawn, the interaction system? Do you remember? Let's look that up really quickly. I'm going into the VR pawn. Okay, I'm going into it. Here it is, okay? Kind of well organized. We got the little levels here. What are these things right here? Do you see these? What are these? You know what that is? It's a comment, right? You're used to writing dash dash in C++ or slash slash. Then you can add a comment to kind of clean things up, keep code separated. Well, guess what? If you right click and then type comment, you can create your own comment there, okay? And then you can even, let's go print string, you can add code into the comment, and then when you move the comment around, all that code will move. So that's a really good way to organize stuff, all right? And we see some of that here. If we go down to where our main logic is, we can see that we used a function. We created a new function to hide away some of that complexity and organize things. This function is called determine hovered actor. And thus, it does a line trace, and it figures out what it hits, and that's the hovered actor. Now, question for you. One of the things that you're supposed to do for P1 milestone is that you're supposed to change the color of your interaction line, right, the line trace, if you hit an actor that has some affordances on it, right? When you interact, when you can interact with something, we want to let the user know that that's possible. So we change the color. So how could you do that? Let's see how you're feeling. Let's see how far you've gotten with programming in Unreal. How could we do that? We want to change the color of the line trace. So where should we look first? Any idea? Yeah.
In line trace by channel in trace color.
Rock and roll. Okay, that's a good start. So if you look at the line trace by channel function, the node, there's a couple interesting things related to color. Now we care about trace color because that's the color of the line. You can also change the hit color, the little thing, the little effect that shows up at the end of the line when you hit something. Now we would like to change this away from red if the user is pointing at something that has some affordances on it. So we need to change this color. That means we should probably create a variable. Let's go ahead and create a variable. I think I could just type create variable. No, I can't. Let's do it down here, okay? I'm going to click plus to create a new variable. Let's call this trace color, okay? This is not a Boolean. It's a color data type. So I'm going to go ahead and grab that. Now I can pull this out right here, and I can plug it in. All right? Good. Now we want this to default to red, and I think I can do that. I compile, and now I can alter the default color over here on the right. So now the default color, I think, let's see here. Yeah. Okay, now it's red. All right? Very good. It starts as red. So we need to make some decisions. We need to add some branching logic that says, hey, if we've hit something that has some affordances on it, we should become, I don't know, blue or yellow or something else. But if that's not true, we should become red, right? So my question for you is, we've got this current hovered actor, which is the thing that we're currently pointing at. How can we see if it has any affordance components? What do you think? How did we do it earlier? Because remember, when you click the trigger, we have to go and find each affordance component and then call its interact function. Do you remember that? Let's go back to the event graph. I'll show you. It's right below it. When we click our trigger in, okay, we're going to check if the hovered actor is valid. We're going to grab all of its components of type affordance using get components by class. We're going to loop through all of them, and we're going to call that interact function on each, okay? So what can we do? I'm looking at this component right here. Let's use it again, all right? We're going to go back into the function. I'm going to say, once you've hit something, let's do this. Let's call that node, okay? Get components by class. And then I want to check how many affordances were on this actor. So let's get the length of this array. Now, if this length is larger than 0, so let's do a greater than check. If it's larger than 0, then what do we do?
Go back to
What's that?
I mean, go back to what I.
Well, we can't go back, but we can do something to this variable, right? What should we do?
Set the color of the variable.
Yeah. Okay. So if we're pointing at something, some actor, and it has affordance components on it, in fact, if it has more than 0, then we're going to set that color variable, okay, that we were using earlier. We're going to set it, what should we set it to? What color should we use? Any idea? RGB, okay? RGB, let's just go blue, 100% blue. How about that? Okay, so we've now got blue that we're setting it to, but if we hit something that doesn't have any components, what should we do? We're going to set the value of that trace color variable. We're going to set it to red, okay? So let's just set it to red. Blue is 0, green is 0, red is 1, and then alpha is 1, so that's not transparent, okay? And there you go. You can add this code into your code base and test it if you want to. I'm pretty sure it will work, right? You might need to use isValid to check that this actor is not null. But other than that, that's pretty much it, okay? This variable, trace color variable, gets set to red or blue depending on the number of affordance components on the actor that we've hit, okay? And that variable, that color variable, gets plugged in to control our trace color, okay? There you go. Not too crazy. Though, again, if you haven't done much of this style of visual programming, it can feel a bit crazy, okay? And it might take some time for this to all feel comfy because you need to know that that function is available, right? Life is easy when you know that the get components by class function is available to you. If you don't know this exists, it's kind of like, where do I even begin, right? Okay, so there you go. Hopefully that's useful. If that task was hard for you to do, you can now finish it up using that code if you want to, okay? Visual programming is a pretty big deal. Sometimes pieces of data or pieces of logic are really well represented. They just fit visual programming, okay? Riddle me this, what about dialogue? Could we use visual programming to organize how our dialogue works? Have any of you played like a visual novel game or an RPG? You know how there's often multiple choices for dialogue, right, that you can say. And depending on what you select, the conversation will veer off in different directions, right? Well, how do you visualize that? You can do so like this. This is a program called Yarn Spinner. This is actually the dialogue from my indie game. And when you talk to someone, sometimes it's very linear, but sometimes you get to a branch where you can actually make several different choices, and sometimes they converge, but sometimes they don't, okay? And so we can use visual programming to represent lots of things including logic, okay? Unreal Engine is the focus of this project. It is very famous. It is the technology behind the world's biggest games, okay? Fortnite is currently, I believe, the world's biggest game, as it has been for quite a while. But it has also been used on other games, right? BioShock Infinite, okay? For instance. It's been used with a lot of VR titles. Creed, Rise to Glory, Vader, Immortal. It's also not just used for realistic or high-budget games. It's used for a lot of indie games as well. It can do more kind of cartoony and playful art styles if you want it to, right? BOGO, Dance Central, stylized stuff, right? A quick note here, right? This is Blueprint Visual Scripting. That's what you call it. It's a bit of an unfortunate name because blueprints refer to both the logic that you see here, but it also refers to like classes, okay? A blueprint in Unreal is literally a synonym for class, okay? So it's kind of an overloaded term, blueprint. Now, did you know that you can program textually in Unreal Engine? Okay? C++, you can write C++ code to build your projects in Unreal Engine, to build your components, to add logic to blueprints, okay? And that's what this looks like, okay? So how do you choose between them? Should you program in C++ or in blueprints, all right? And the answer is subtle. So with the blueprints over here, you can actually compile your code in the editor very quickly, okay? It's a pretty good time. If you want to compile and use C++ code that you've written, there's a good chance you'll have to restart the entire editor, okay? Every time you make a change. So you know how it sometimes takes half an hour for Unreal to open a project? Imagine that every time you write a new line of code and want to test it, you have to reopen it and wait another 30 minutes. Doesn't sound so good, huh? When you make a mistake in blueprints, when you have a bug, you'll get an error message, but the program keeps running for the most part. It doesn't crash out wholesale. However, if you have an exception or an error in C++, all of Unreal will crash, okay? It'll just go away. Not so fun, all right? And then you'll have to reboot Unreal, and it'll take 30 minutes. And if you can't figure out what the crash is, well, it's going to crash again. In general, with blueprints, we can learn about Unreal, and we can move a bit faster, at least in the short to medium term, okay? In C++, you have to deal with all the difficulties of the C++ language, but there are actually a lot of additional things, macros and stuff like that, that you have to know or you'll get blown up in Unreal C++. Do you remember std vector? How many of you have used vector before in C++? Okay? If you use vector in Unreal Engine, you're dead. Okay? You're going to crash. It's going to fail. All right? Because Unreal Engine has created a set of its very own containers and tools, okay, and data types, right? Don't even think about using a string, right? Unreal has their own version of string that you're supposed to use. And if you don't know this, you're in for some pain, okay? This is all to say, sometimes Unreal C++ is not called C++ at all. Sometimes it's just called Unreal++ or U++, okay? And that's because it can feel like a little bit of a different language. Okay, this is all to say Blueprint is where we're going to be focusing on in this course, okay? There is a lot of value to learning Unreal C++, but we don't have enough time. We also have to learn Unity, okay? And then we have to do our final project. So I'll encourage you, if this doesn't feel good, if you are hoping to learn Unreal Engine C++ at a lower level, you can still do it, okay? I have a really great video for you to watch that does a wonderful job of talking about it. And there are also some really great C++ tutorial series online for Unreal. I encourage you to check them out. But in terms of learning that in this course, not going to happen, all right? So why visual scripting? Okay, what's the point? Well, if you look at the textual C# code that we have right here and the visual code that we have in Unreal, these are both doing the exact same thing. However, there are some advantages to each, okay? And what I want to focus on is that on the left here, right, this literally looks like the Matrix, okay? People who are not used to programming will look at that text and they have no idea what's going on. None. Okay? They don't know what void means. They're going to forget to write it. Okay? They don't know what these little brackets mean. They might forget to include it. They don't know what the semicolons mean. Right? How many of you have ever lost time to the classic, oh my goodness, I forgot a semicolon on line 7. That's why it wasn't compiling. Right? So you can understand that when it comes to textual programming, there are so many ways to mess up. You can shoot yourself in the foot so easily, okay? But over here, there's no way for you to mistype. There's no way for you to forget a semicolon, okay? You'll often see comments like these. J.G. Harding, I think on the Reddit game dev subreddit, says, hey, I have no real code knowledge but come from an art background. So it's Unreal for me because of blueprints, okay? I think it's the more friendly of the two versus Unity, all right? And that is a pervasive thought, okay? One of these looks like the Matrix and is very intimidating. It's always breaking. You have to get everything perfect, down to the letter. And this looks like Legos, okay? You just kind of create some Lego blocks and then stick them together as you do to Lego blocks, and it works. No problem, right? You can't mistype anything. You click right on your little clicker, your mouse. You click the right mouse button, then you just search for what you want, and you hook them up, okay? No big deal, right? You can even manipulate this right here. You can manipulate the Unreal blueprint so that it actually looks kind of similar to the way that the textual code is laid out, okay? These red blocks are your functions, and then indented from them are the lines of code that will run one after another, okay? So not too bad, all right? So on the left, with textual programming, you have a lot more you have to do and understand and know to see the underlying relationships between variables, functions, and the class that's all in, okay? But over here, in the Unreal Engine blueprint visual scripting, the relationships are a lot more obvious. You just follow the lines, okay? You want to know what the execution order is? You just follow the white line and read the Lego blocks, okay? No big deal. Over here, you get tons of syntax issues, and any typo will bring you down. But over on the right, there are no typos, okay? You cannot type or misremember any syntax. For instance, if you want to move an object, right, using the add actor world offset, you cannot type add axtor world offset, all right? This is not a node, okay? It will not appear, all right? So over here, programming is terrifying. I can't do it. Over here, people will say this isn't programming, it's blueprints, right? It's not programming, right? So an anecdote, one of our local studios is a team called Azure Ravens Entertainment. They make a bunch of games for mobile. They make games that are a bit more realistic with Unreal Engine. This is what their studio used to look like. I took a photo. Now it's way nicer. They were like in a closet during that time. Now they're in like a beautiful studio. They've got wonderful windows. This is Corbin Reeves. He teaches game dev at EMU and Kettering. And he told me, we will prefer Unreal Engine over Unity any day of the week, okay? Our team is very art heavy. We only have one programmer. We don't have many programmers, so blueprints are a godsend for us, all right? But what I want to convince you of today is that blueprint scripting, all right, blueprint programming, visual programming is exactly the same as standard programming, okay? Everything that you can do in C++, in EECS 280 and 281, you can do it here as well, okay? You are not trying to learn in, a set of underlying new weird principles here. What you're actually learning is how to do the things you already know, but in a slightly different syntax, okay? You're training your eyes. Your brain can already do it, but your eyes need to be updated, okay? So let's talk about variables, okay? I want to create a new component, okay? i.e. a new class. I want to create a new component that I can stick onto any actors that I want, okay? And I want that actor to gain health and speed and an inventory, okay? Stuff like that. Things a character in a game should probably have. So I create a character data component, okay, like this. You see it? This is a component, if you can believe it or not. Now, this component, this blueprint, does not have much logic, okay? It just has an empty lifecycle function that it's not really using for anything. But it has some variables, right? It has a bunch of data inside of it. It has a health, which is a float. It has ammo, right? It has all the things you'd expect. It uses a bunch of built-in data types. Float, string, Boolean, right? You can see here, interestingly, this is also a string, but it is an array of strings, okay? Not a singular string, but an array. We can also see that this is not an actor, it's actually a set of actors, okay? Now, what's really cool here is that you can have the built-in data types like float, string, all that, but you can also have custom data types, custom variables. In this case, we have a variable called biscuit preference, and the type of that variable is called big biscuit, okay? This is not a built-in Unreal Engine data type. Epic Games is not obsessed with biscuits. This is something that I made. Because once you create a blueprint, once you create a new class, you can now use that class anywhere, just like in C++ or C#, okay? You got container types, you got array, set, maps, okay? Yep. If you look at the variable and then move to the right side of the editor, you'll actually see here, right? You can change the variable type from a single to an array, a set, or a map, okay? You can even mark it as private or public. So you're very used to reaching out to an object and manipulating its data. But sometimes you don't want that. Do any of you remember what encapsulation means in the context of object-oriented programming? Anyone? In object-oriented programming, you create classes, right? And those classes contain data, variables, right? And functions, logic. A principle of encapsulation is very core to object-oriented programming, and it says that, hey, in general, if someone doesn't need to use a variable, let's make it private, okay? Make it private. We're going to use that variable internally within the class, and if others need to use it outside, we'll make it public, okay? So there you go. It can also support default values, okay? Remember the color variable that we created, we said, hey, the default value is going to be red, okay? And we set that up. Another super cool thing with variables is that you can click the eye. Remember the eye? You click on that little eye icon and you're marking it to be editable in the inspector, in the details pane, okay? This is super nice, all right? Imagine that you've got a bunch of designers on your team who do not know how to program in blueprints. But they need to make the game, right? How are they going to make the game? How are they going to build out content and interactivity if they can't program? Well, here's how. You are going to write code, but you're going to make the variables viewable and editable like that, okay? When you do that, when you click that eye, let me see here. When you click this eye, right, we've got a character data component right here. It's tiny, but you can see it. We've got it on this chair, all right? If you look at this character data component, click on it, you'll see that now the favorite foods variable is available. It appears in the inspector once we've clicked on the component. In this case, we are now able to customize the favorite foods that this chair has, okay? And we added Notai, Totoro, and Ginger Deli, okay? So this is a way for less technical members of your team to edit the game, add content, change things without writing or editing any code at all, okay? Super important to have this. I'm not sure why a chair would have favorite food, right? But I guess that's the point of writing a component like this. Maybe you decide that there are 100 chairs in this game, but one of them is like an enchanted chair. It's like basically a human whose soul was bound to the chair. So the chair, this chair, should have favorite food. Okay? So there you go. This is not just variables, but also functions. Okay? Functions, one of the most popular and early methods of code reuse and cleanliness and organization that you learn in EECS 280 or even EECS 183, I think. Okay? Or Engineering 101. So we've got our variables right here, but just above it, we have our functions pane, okay? It's right up there. And basically, what you're doing, when you create a new function, when you click that plus button, you're basically creating a new node. This node is something that you can search up when you right-click and you want to call that function, you want to use that node. There you go, okay? So let's say that I have a function here that I've created. The function is called find all Notai lovers. Okay? So the idea here is I want to get a reference. I want to find all the actors who love Notai. Okay? You can customize the inputs and outputs of your functions in the same way that you can add parameters and return values to your C++ functions. Okay? So if we look at find all Notai lovers, if you think about it, what should this return? What should it take and what should it return? I don't think it needs to have any input parameters, but it should probably return something, shouldn't it? Yeah.
An array of type levels.
Yeah, an array of type actor, probably, okay? We can manipulate the inputs and the outputs by going to that right side editor, right, the inspector, the details pane, and changing and clicking the plus button, okay? So in this case, one thing you might do is you might say, hey, I want my function to be customizable. I'm going to give it a float parameter, proximity to search, okay? So we'll only search for Notai lovers within this distance from Ann Arbor. We can give it a location. So maybe we don't want the Notai lovers in Ann Arbor. We actually want the Notai lovers in Ypsi or in Detroit, okay? Maybe we want to know what specific dish at Notai people like, okay? So I only want to find Notai lovers who love drunken noodles, okay? So there you go. You can do that kind of thing. On the return side, right, we can set it up so that our return value are a set of actors, okay? I didn't do an array of actors, I did a set. Why would I do a set? Anyone know?
So they're unique.
Yes. The difference between a set and an array is that the array can have duplicates, okay? The set cannot. So, can you think of a reason why we'd ever want to report the same Notai lover actor twice or more? Can anyone think of a reason to do that? No, that wouldn't make any sense. In fact, we would consider that a bug, right? So we say, oh, I only want to know each Notai lover. Don't put them in my container more than once, please. And so we'll use a set. That basically guarantees that. Okay? There you go. All right. So I have a question for you, okay? I think I was going to ask you, okay, what does this do? But I think I'm not going to do that. I'm going to ask you to look at this, okay, look at this function. Let's take about 30 seconds and see if you can understand how it works, okay? This is a very powerful function that does a lot of things, okay? So how does it work? If you're too far away, you can watch the live stream, twitch.com/ayarger, and you can see it on your own laptop or computer, or you can wheel up here or walk up here, whatever you want to do. Okay? I'd like an explanation of how this function works. How does it identify all the possible actors that love Notai? Remember, in Unreal Engine, anything in the game is an actor, basically. The chair is an actor. The cube is an actor, okay? The VR pawn, the player running around, that is also an actor, okay? So who has a feel for how this works? Go for it.
For all actors of class actor, make the current actor the current actor. Check the favorite foods of the current actor. If favorite foods contains Notai, or one of them is Notai, add it to the Notai array. At the very end, return the Notai array.
Yep, very good. Okay, let me walk you through it, all right? Our mission here is by the end of this function, by the time we get over here, we want to have this result variable containing every actor who likes Notai. But how do we know if a given actor likes Notai? Well, what we do first is we use the node get all actors of class, okay? This is a very powerful node. You should memorize this one. This will get you a reference to every single actor that's derived from a certain class. Do you see what class we use? What class do we use? Actor. I.e., what does that mean? Get us every single actor you have. Every last one, okay? We iterate through every single actor. We grab the component of type character data that that actor has. Maybe it doesn't exist, okay? Maybe it's null, all right? Then, if we got it, we iterate through its favorite foods array because the character data component has an array of strings, right? We've already seen that. So we iterate through it. We check if any of those favorite foods are equal to Notai. And if the answer is true, we add that actor to our final result set. Okay? And there you go. If you saw this code in C++, it'd be easy for you to read. You'd understand it right away. Okay? But you'll get used to this. The important thing here is remember that these nodes, these functions exist. Okay? Get all actors of class, super powerful. Okay? And get component by class is super useful as well. Okay? All right, use functions to keep things clean. Once we've created this function right here, we can use it. So in this case, look at this. Every frame, every single frame, so 60 times per second, we're going to find all those Notai lovers, okay? We're going to check, all right, how many are in this set. We'll get the length. And then we're going to print how many of those exist, okay? So you'll see a message like 5 Notai lovers exist. And that'll show up in your console, boop, 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 60 times per second, okay? So there you go. When it comes to comments, we already talked about these, but you can right-click, you can type comment. Instead of looking for a normal function or node, you go for a comment, and you can begin using it, okay? You can make the comment really big. It's kind of like an area, and you can stick nodes into it and use that to organize yourself, okay? It feels kind of like a function, but a little bit less formal, right? Question?
What about commenting something out? Like if you're not sure about changing
Yes.
or something?
If you want to comment something out, you should ask yourself this. How do any of these nodes get run in the first place?
Sure. So just take it out of it.
What I would do, if you ever want to delete this white line, this is a really annoying thing, you hold Alt and then you click on it, okay? Hold Alt on the keyboard and then click on the white line. The white line will disappear, okay? No idea why they did this. It takes everyone a while to find this, okay? But there you go, all right? Hey, so let's talk about classes, okay? And the most important thing for you to understand about classes in Unreal Blueprint scripting is that blueprints are classes, okay? They are classes. I'll prove it to you. Let's go into Unreal Engine. What kind of class do you want to make? Anyone? Any ideas? Maybe you're wanting to make a Mario game. So let's go make a Goomba class, okay? So let's right-click. I'm going to go to, let's create a blueprint class. They even put the name right there in case you're confused, okay? Now, the Goomba is like an enemy, all right? It has some visuals and stuff. So I'm thinking actor. Let's create an actor class. And I'm going to call this class Goomba, okay? I can double-click on this class and look at that. It's empty. There's nothing here. But if you look at the variables, if you look at the functions, right, we can now begin putting data into our class. So I can have a is defeated Boolean. I can have a health. Let's not make it Boolean. Let's make it a float, okay? Floats are basically doubles with less precision, okay? So we can create an entire class just like that. And now we can use the Goomba class anywhere. Let's go to AF open URL. Do you see this? Now, we shouldn't do this, but what if I wanted to get that Goomba? What could I do? Well, I could do this. Get actors, get all actors of class. I want to get all the Goombas, so can I search Goomba? Yes, I can. Okay? This right here gets me all the Goombas and puts it into this array, and now I can do whatever I want to them. What should I do to them? I'm going to iterate through each of them, and I'm going to go ahead and destroy them all. Okay? So there you go. I just wrote some code that's going to find all the Goombas, and they're gone. All right? Rest in peace. Now, we wouldn't want to do this in the AF open URL component because destroying all the Goombas has nothing to do with opening a URL. This would make no sense at all. Nasty code. Okay? But hopefully you agree with me now that, yeah, blueprints, you can create them really easily, and they're kind of basically classes, okay? Right, if you see code like this, you're almost certainly inside of a class or a blueprint. You're looking inside, okay? Now, you should ask yourself, of course we are, right? Where else could we put data and functions, okay? You put them inside of a class. Every time you create a new blueprint or a blueprint component, you're actually creating a new class with everything that entails, okay? You've created a new class, which means you can now search for that class. You can now instance that class, okay? So you created a new class, which means you can now bring it out into the map. Or if you created a component, you can now add it to other actors. So I can actually bring this Goomba out. Do you see it? Look at that. I've got my Goombas. I'm instantiating it because that's the thing you do with classes, right? Now, you can't see them, but wait a second. If I go into the Goomba class, maybe I can make it visible. Can I add a new component? Let's add a component. Let's add, can I add a static mesh? Okay, a static mesh, and I need to give it a model. So let's give it a nice big cube, okay? All right, now all of my Goombas look like cubes. Let's make it a bit flatter because Goombas are kind of short, right? And I'm going to move this cube, right, so it's centered a little bit more, okay? Okay, compile, Control-Shift-S, right? When I go back to our map, suddenly I see a bunch of Goombas, okay? Because editing the class will propagate that change, propagate that edit to all of the instances of that class. That's how classes and instances work, right? So anyway, I guess I'm just trying to prove to you that all of your knowledge from 280 and 281, it's valid here too, okay? Don't forget that. It's a very powerful feeling. All right, anyway, let's keep going. You can find new types that you make, new classes that you make in the content drawer, okay? They're in there somewhere. You just got to look a little bit. For instance, you might see Big Biscuit, okay, hanging out in there if it's your new class. You can reference those new types in code, right? That's kind of what we mean when we see that you can now create variables of that new type, okay? You may instantiate instances of that class, as I just showed you. Here's another video showing that, okay? So we've taken this table that we have out there, we're turning the table into a new class, okay? Here is our new class. It's called Table Blueprint. We can add code and logic to that class if we want to, and we found the class right there. We can just instance that class as many times as we want by just dragging it out like this, okay? There you go. Cool. You can use functions when you're scripting to find all of the instances of that class if you want to. So if we want to find all the Goombas, right, you'll use get all actors of class. And you'll specify, hey, I only want the Goombas. Okay? Find all actors of a given class. And then once you've got that particular actor, you can grab its components if you want to by getting get components by class. Okay? So there you go. We used both of these in the find all NoTie lovers function. And as you work on P1 alpha, I encourage you, refer back to this function, okay? It does a lot of things that you might find useful. Okay. I think we're going to talk a little bit more about classes, and then we'll go ahead and we will take our 5-minute break. We're a little bit over halfway through. When you look at a C++ class, you're used to seeing this, correct? Right? Now, I'll be honest, I don't really like this syntax. I much prefer the Java or the C# syntax for classes. But you can see here, right, that we've got two variables that are packed in to this class called human. But we also have three functions that are on this human class as well. All right? If you look at this class, you can see the same thing. All right? You can see that, oh, this class has two variables. It has an interests array. This array has an interest data type, okay? Likewise, up here we have a vector of type interest called interests, okay? We have a float down here called happiness, all right? And we have a float up here called happiness, all right? We've got those three functions. They are right here under the functions panel. You can override them. You can add logic to them if you want to. So understand, right? You're basically just trying to retrain your eyes, not so much your brain, so that you can see these things that are already there and that you do already understand, okay? We're going to go ahead and create a class here really quickly, okay? We're going to go into our project pane. We right-click. We go to Blueprint Class. Click. I want to create an actor. We're going to call this actor human. When you double-click on the actor, we go inside of it, right? We go inside of the class, inside the blueprint. We add all those variables that we wanted to have, right? Interests. We could say that is of type interest, okay? That is another custom blueprint, custom class we made, okay? Turn it into an array so we have many interests and not just one. We're going to create that happiness float. Okay, currently it's the wrong type, but we'll change it to float right there. Bingo, there we go. And then we can create those three functions. Eat, sleep, right? Talk, okay? And there you go. We now have that class. It's as if we typed it in Notepad++ ourselves, all right? Okay, there you go. So the takeaway here, right, and hopefully I am definitely pounding in the same idea, but I really do have to pound it in. Blueprints are classes. The terminology is a bit different, but they're the same thing, okay? So the sooner you can take your mental model from 280 and 281 and get them working in Unreal, the better you're going to be, and the nicer this P1 is going to go for you, all right? However, there are things called data-only blueprints, okay? Can you guess what a data-only blueprint is? Has anyone ever heard of a struct before? Now, structs can contain functions, but they usually don't, right? What do structs usually do? What are they for?
Holding variables or groups of variables.
Yeah. It's like, hey, I've got like 5 different variables and I kind of want to pack them all together. So let's put them in a struct, okay? That's what you do in C++. Well, in Unreal, often you have a class that is only carrying data, okay? And that is basically a struct, all right? And this is actually what it looks like, okay? Usually you've got the big viewport, you can see the blueprint's visuals, but sometimes if it's data only, you'll just see this list of all the variables, okay? And so there you go. Let's talk a little bit about inheritance, but I want to do that when we come back, okay? So let's do that when we come back. I will see you in 5 minutes. Use the restroom. Maybe get your P1 Alpha going. Talk with your teammate if they're here. And I'll see you in 5, okay? See you then. I think we'll mention it. The thing to know about casting is that if you have a reference to a type in the inheritance chain, and that reference is less granular. Let's say you have a reference to an affordance, but you know that this affordance is actually half open URL or half target. Well, you can cast it. Sure, you're sure this is going to be true. Cast it down to that more specific lower in the inheritance chain, and when you do this, you'll gain access to all the unique custom features that only specific component has. So, however, in some cases you'll go the opposite direction. So you can have an half open URL reference or a variable or something, and you say, I really kind of want that to be normal affordance. Now, it is already an affordance, so it's really easy. You can actually cast it to be inherit type. Now, by doing this, you're losing the unique features and variables and functions that only half open URL has. You're losing those. But you probably still have all you want. Probably that interact function, which all affordances will have. Right? So that's why you want to have it. No. Yeah, that's weird. That's bad. The nice thing about being engineers, programmers in particular, is when GPT pushes us, we usually know like 5 seconds. The problem that like the legal profession runs into with GPT is that GPT will tell them something that sounds perfect, but it's actually wrong, and the legal scholar has to spend a day and a half determining that it's wrong or not, because they have to go into the sources, they have to find the sources. Maybe that's hard. They have to get in there. Maybe GPT used a relevant source but summarized it incorrectly, right? So, huge pain. Yeah. You're welcome. Okay, ladies and gentlemen, let's get back to it. Not a whole lot left to do, but we only have about 20 minutes remaining. We'll go ahead and get out of here. Let's talk about inheritance, okay? Where you have classes, inheritance is almost surely to show up. Usually, just about the second main major method of code reuse that usually gets introduced in introductory programming courses, okay? You've got functions, but what happens when you want classes to share with each other, okay? What happens when you've got a great class, but you want to change something about it? You want to specialize it, okay? You've got an enemy class, but then, the Goomba enemies are slightly different. They need some unique stuff, okay? They need some unique variables, some unique functions, but then you've got the Koopa enemy right there beside it, which is a specialization of that more generic enemy class, okay? Well, what do? You use inheritance, okay? And inheritance is everywhere in Unreal Engine. Unreal Engine loves inheritance in a way that Unity really kind of doesn't, okay? Unity uses a bit of it, we'll get more into that later. But if you look inside of a blueprint in Unreal, you are looking inside of a class. And classes in Unreal will almost always inherit from something, okay? In this case, if you go into a component, for instance, that AF_OpenURL component, let's see, there it is, double click, we can see that it is derived from the affordance parent class. After all, that's why we have the interact function, okay? If we open that Goomba class, we can see that the Goomba is a child class of actor, all right? Which means it'll get all of the stuff that you'd expect inside of an actor. Variables will be there, some functions will be there, all that good stuff, all right? So whenever you create a class in Unreal, know that you are deriving from something, okay? And whatever something you choose, that's going to have a big impact on what you could do with that thing that you're making, okay? I want you to look at this right here. This is a Goomba class, right? What type of it? What type did we derive from to create it? Do you know? What is the parent class of Goomba? Any idea? Yeah. No, it's an actor. And you can see that right there. And if you go into it, you can see the parent class is actor. This Goomba, we derived it from actor. And that means we can drag it out into the scene and map really easily, right? Cool. But you know what we can't do? We can't go to the door actor and add this as a component, can we? Oh, wait a second. Yeah, we can. All right. I guess we can. I think it transformed it. Oh, a child actor component. Yep. Okay, I got it. Makes sense. This AF message component or AF open URL, this is derived from affordance, and affordance is derived from actor component. That means that we can easily just bring it up here and attach it as a component to other actors. When you go to create a new Blueprint class, your first decision is what will we derive from? Pick a parent class. If you pick actor, that's the most general purpose one you can do. That's fine. You can pick actor component if you know that you're creating a component. You're going to do this a lot on P1, okay? You're going to create a lot of components. So choose actor component. But you could choose character or a pawn if it's something that the player is going to be controlling. It needs functionality related to inputs. It needs network replication, right? You might choose a pawn or a character. Or you can click on all classes, and now we got all of this stuff, including our Goomba. Okay, we could derive from our Goomba if we wanted to, all right? So just know that whenever you create just about anything in Unreal, you're creating subclasses, okay? You're deriving from something. So like in other languages, public variables and functions will exist in the derived class. It'll flow through the parent into the child class. And you can override those functions if you want them to do something unique. If you recall, we had a class called affordance, right? Here it is, our blueprint called affordance. The only thing this class has inside of it, if you look, is that one singular interact function. But that's all we need. If you create a new class and you say, oh, I want to derive from affordance, that new class, blah, 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 okay? That new class is going to have that function inside of it, okay? If you look inside your functions override, look at that. Interact, right there. Found it. Okay? So, anyway. All right. Yep, and you can see that here, right? So you can override from any function that you've gotten from your parent class. And sometimes you got quite a few functions, right? So depending on what your parent class is, you might have like 20 or more different functions you could override and change, okay? In C++, inheritance tends to look like this. You've got your human class that we saw earlier, but you'll have some other classes. So a professor is a human. Professor derives from human. That means the professor gets happiness and eating and sleeping and talking functions and interests, because it is a human. But the professor also introduces a new function exclusively of its own called teach, okay? But you can also have other classes deriving from that same class. So student is also a human, right? So it gets eat, sleep, talk, it gets happiness and interests, but you can see that the student has overridden the eat function, and it has also overridden sleep. What do these functions do? Can you see what they do? They do nothing, okay? And this is an accurate design because students don't eat and students don't sleep, in my experience, okay? All right, deriving from human. I think I've got some footage of us literally doing that, okay? We have a human class right there. You can go and create a new blueprint class. You say, I want to derive from human. I'm going to create a student or a teacher, okay? Which one, what do we call it? We're going to call this student, okay? Once we double click and go inside of that class, right, we can see now we're deriving from human. And if we look in there, we can see sleep and talk and eat right there, okay? There you go. You can now go take eat and you can do nothing, right? Or in our case, when we eat, we're setting the happiness to 1 billion, all right? So unlike normal humans, when a student eats, they get super happy. That's what this logic is basically doing. That's the design that we just saw. Now, I'm not sure if that's accurate or not. Do you get happy when you eat? Like, okay, sometimes. I used to go and get no-tie after a really bad exam, and it would basically fix my mood. But that was as an undergrad. Okay. All right. Polymorphism is a fancy word. It's kind of fun to say, all right? And it's a really important thing to know about for things like interviews, okay? Where polymorphism will show up from time to time. What is it? Does anyone know? I'll give you a hint. It might jog your memory. There's something really cool that you can do when you're using inheritance, okay? And we already did it. In fact, the way that our affordance system works, it works by using polymorphism, okay? Let me give you a hint as to what I mean and why it's so cool, okay? When we go into our VR pawn, do you remember how it works? The VR pawn has this variable, current hovered actor, okay? And this current hovered actor will get an actor put into it. No matter what you point at, it's going to go into that variable. Now, when we press the trigger here, let's go out here. Here it is. When we press the trigger, we're going to grab that actor that we've been pointing at, okay? We're going to get all the components on that actor, but we're only going to get them of type affordance, okay? We're going to get an array of affordance components, okay? That's the output. We're going to grab a bunch of affordances, but I want you to tell me which affordances are in that array, because they could be message affordances, they could be toggle affordances, they could be the open URL affordance that we keep looking at, right? How do you know which ones are in this array? How do you know? You don't, right? There could be 5 open URL affordances in this array, depending on what we're pointing at, but maybe there are none. Maybe there's a mixture of message affordances and an quit affordance, and an open URL affordance, an play sound affordance, right? It's a mixture, and we don't care what kind of mixture we've got, because you know what every affordance in there is guaranteed to have, no matter what. The interact function. Bingo. We don't know exactly what class that we have, but because of polymorphism, treating derived classes as if they are the parent type, we don't care. what kind of affordance we have. We're going to treat them all the same. Because we know they all have an interact function, we can just call it, even if the individual interact functions behave a bit differently, right? AF open URL is going to have a different interact function than AF message does, and that's going to be different interact function than what AF quit does, right? And so that is what polymorphism is. You have many different things, but you're going to treat them all the same by referring to their parent class. That's it. It's not so complicated when you think about it, and actually it's super, super useful. This is the reason our interaction system works at all. We would be toast if we didn't have this, if it didn't work, okay? So that's what polymorphism is. Let me give you a slightly more formal example. This one's very typical, okay? We have a base shape class. But the shape class is just a parent class. It doesn't really, by itself, have enough information to be useful to us. So we have more specialized classes, like the circle class, the rectangle class, the square class. Now, I would argue that a square is a rectangle, so the square class should probably be down here, but that's not a big deal, okay? Now, the shape class has a draw function. So all of our derived classes will also have the draw function. But you draw a square differently than the way you draw a rectangle. And you draw a rectangle differently from the way you draw a circle. So if you want to draw all of these things, you don't need to first get all the circles and then draw them, and get all the rectangles and draw them, get all the squares and draw them. No, you're going to create an array of type shape. And now you can put all of these child classes into that array, and you can call that draw function on all of them. Easy peasy, okay? Super, super nice, no big deal. So use a base class, in this case shape, to reference a bunch of uniquely derived classes in a standardized way, okay? This simplifies your code dramatically. That's very, very powerful and very elegant. It allows you to kind of scale out logic and build new components without worrying about the selection system. It is just going to work, okay? So anyway, we use it for our affordance architecture, so that's what makes our life so nice, okay? All right, so let's talk a little bit about debugging Unreal, okay? This is a pretty big deal. Unreal blueprints, right? Not super difficult, but you can still mess them up. You still need a way to debug them, okay? Now, the classic technique that everyone loves to use but no one loves to admit is debug by printing. Debug by log, okay? By the way, everyone uses this in industry as well. They sometimes like to pretend they don't. But here's what it looks like, okay? You've got your STDC out. You print some sort of message. Is it working? If you see the message, you know it's working. If you don't see the message, it's not, okay? A true classic, all right? Print string is the equivalent here, okay? You're going to print a string, and if you want to print a variable, you can actually plug the variable in and print and see what it is, okay? So you might do something like this. If you want to print the current health in your component, in your class, right, you can have print string. You can append some strings together. In this case, we're appending health, to the actual health float value. And so you'll get something like health, 100, or health, 50.72, whatever you want, all right? You'll see something like this, okay? In this case, we see health equals 0, 0. You'll also see this in the output log view, where you can actually scan and filter for certain messages, okay? So if you're struggling with some of your P1 alpha tasks and you're trying to figure out what's going on, this is a really good thing to do, at least in the short term, okay? Now, you might need something more heavy duty, okay? If you've got a big problem and it just the print statements aren't working for you, you can visualize what's happening in your blueprints, okay? If you play your game but keep the blueprint window open, and if you select a certain component or object, you can watch the blueprint in real time. You can see the execution is going to it, and we're just printing tons of hellos every frame, Okay? So this can be kind of cool if you don't know how execution is flowing through branches, for instance. You can watch and see how it's flowing through using this, okay? But you can do some more as well, okay? You can do some more. Let's see. You can do breakpoints. You can watch variables, okay? You can look at the value of variables as you watch the game run. So let's go into Show Debugging Stuff component. If you ever want to edit a component, you can right-click on it, and you can go to Edit the component at the bottom. There we go. Our component, the guts and logic of our component are now available. Okay, we've got a special number variable, and we got some logic here. Okay, the variable is getting set to different values as we go down the script. So you can right-click on any function you want, and you can click on Add Breakpoint. This will create this red little stop sign right here. And I believe if we play the game, I'm going to click on a variable, and you can watch that variable as well. So now when we run the game, we should be able to see what the value of the variable is. Okay, we hit the breakpoint, right? The game has stopped, okay? And we can now get a message telling us what the value of this variable is, all right? So this is a really powerful way to see exactly what's going on at different moments, at different lines, at different functions and nodes in your script. So see, we've just did a step forward, and now our variable has turned from 0 to 1, okay? And we can continue moving forward, continue jumping, continue moving, okay? And yep, there you go. You can see the variable has ended up becoming 2. You can click Debug and go to Blueprint Debugger, and you can just have a window that's constantly telling you what your variables are as well. All right? So it's a little bit that you have to get used to, the various UI elements in here, but it's super valuable. Okay? My final piece of advice is if you're running into really weird issues with Unreal Engine, it could be a bug in Unreal. Unreal, very, very buggy in our experience, okay? Not super stable. It crashes a lot. And sometimes it just flat out doesn't work the way that it should be, all right? Sometimes you have to try, turn it off, turn it on again. I want to talk briefly about context-sensitive search, okay? Now, you can right-click. You can right-click and you can start typing just like this, right? You're used to that, all right? You're very used to doing that. However, if you give Unreal a bit more information, for instance, about what one of your parameters to that function will be, then it can do a much better job of tailoring what kind of functions it shows you. So here's an example. Let's right-click here. We're going to type set physics linear velocity, okay? This is the function that will give your actor some velocity. Now, do you see it in here? No? You don't see it, do you? You don't see it because you are inside of a component. And a component doesn't have velocity, okay? So you can't really use that function here right now. Unreal is trying to protect you and tell you, hey, you don't quite have what you need to call in the velocity function to change it, right? So here is what you can do. If you want that function anyway, you can click this little checkbox in the corner. By default, it's on. It says context sensitive. If you get rid of that checkbox, suddenly you can see every available function, including the one that you wanted, set physics linear velocity. Okay? So you can grab that if you want to. We just grabbed that function, and now you need to get an actor reference to plug it into. How can we get an actor reference? Anyone remember? If we are on a component, we're writing code inside of a component, that component is on an actor, we want to get the actor that we're on. How do we do it? Get owner. So what you could do here is you could use the get owner node, which will have an output of type actor. You could feed that in, boom, right there. and that is how you could use that set physics linear velocity function, okay? So another cool thing you can do is you can drag a node, and when you release that node, it will change the results. So how many of you have done this? I'm about to show you this, okay? Let's go ahead. We've got the current hovered actor variable, right? How many of you have ever done this? Click, drag, release. You've done that? If you're not doing that, you should do that more often. It's very tempting to say, "Oh, I want to call the set physics linear velocity." So I'm going to right-click, set physics linear velocity, okay? And there you go. I found some functions, all right? But here's a better thing to do. Click it, drag it, set physics linear velocity. I'm not sure where it went. Where'd it go? Actor object. Let's do something like destroy actor. How about that? Yeah, there you go. Boom, like that. Notice Unreal will automatically plug that node in for you, okay? So I highly recommend doing it that way if you can. It'll help Unreal help you out. You'll have a nicer life, okay? You might need to uncheck that context-sensitive checkbox to find exactly what you need. That was a big thing that stumped me when I was learning Unreal a few years ago. And please be careful. Sometimes different nodes have a very similar name, or sometimes the same name, okay? If you saw that, we searched for quit game, right? We searched for quit game, but there were actually 2 quit game functions. One of them would not have worked. One of them was like a weird online-only version, all right? So you got to be careful. Please be sure to check the input and the output parameters, and specifically their types, very carefully. If someone has a big problem and they can't drag a node in, this is usually what happened, okay? The function they chose has the correct name, but not the correct parameters. So you need to go look up the right version, okay? The last thing I'm going to tell you about, then we're going to go ahead and check out, okay? Go enjoy the weekend. Unreal Engine source code. How many of you like open source, or you look at some open source projects from time to time, okay? Open source is really great. It allows you to learn easily. It allows you to look up, how does this code work? How does it run? You can even compile it yourself, or you can work on it and submit fixes and patches if you want to, or add new features. Well, Unreal Engine is not public domain, but it is open source. You can get the source code to Unreal. You can build Unreal on your laptop. Now, it might take all day, but you can do it, all right? So sometimes, blah, 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 blah. Okay. If you ever want to look up the C++ source code that makes a certain node work, I've got a video for you you can watch, and you can get into it and watch that if you want to. You must jump through some hoops in order to get access to the Unreal Engine source code on GitHub. But if you go to this link, you can get access and explore it if you want to. All right? Let me see. A source build of the engine, blah, blah, blah. Okay, building Unreal Engine from source. That's a really good first step whenever you get into a new open source project. I've built the Godot engine from my laptop, and you'll learn how to do that. And you'll actually learn how to edit the Godot engine if you take the Game Engine Architecture course. But it is all available for free, and it's a pretty good time, okay? If you really want to deepen your knowledge, then you should do it. If you do end up going into Unreal C++, you will find yourself in macro hell. You see these U-class generated body? These macros will basically insert a bunch of code into your class that helps Unreal set that class up. It basically helps establish a form of reflection so that Unreal knows about this class, about this type that you've created, okay? Visual Studio is pretty bad with Unreal C++. I think there's some other IDEs you can use. Blah, 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 blah. You can't use string or vector. You have to use Unreal's version of these. The way that Unreal names its class types is a big deal, okay? You typically need to use U or A as prefixes to your file names. U for object, and A for anything derived from an actor. And blah, 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 blah. It's a fun challenge. I do recommend it. Check it out if you have some time, okay? And I think that's all I've got for you. All right. Does anyone have any question about programming in Unreal? Again, the main takeaways here is that when you're programming in Unreal, you're just programming as if you had any normal language, okay? It just looks a bit different, all right? That's it, all right? So if you're not familiar with inheritance, if you need a refresher, you can look that up in any language. Remind yourself what polymorphism is and why it matters, why it powers our affordance system. And one final thing I'll tell you, it is very tempting on this project to create lots and lots of affordances, right? You're going to use that nice interact function that we set up. However, not every task on your P1 task spreadsheet needs an affordance, okay? Don't be afraid to just create a normal component, okay? A normal component that doesn't have the interact function might be all you need, all right? So anyway, yeah, have fun, all right? Have fun with P1 Alpha. This is a tough week, not gonna lie, right? I think the course actually gets easier after this week. But do the best you can, all right? Start early. I'm going to be around for the next hour. If you want to get started, if you want to ask for some tips, do some debugging, I'll be here. Otherwise, I'll see you on Monday, okay? Have a fantastic weekend, all right? See you then. All right, everyone watching on Twitch or at home, take care all. Have a good weekend. Bye-bye.